Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows Compiler. Today we will look again at our form application and start to use a dynamic link library. In our application at the moment, we have a PBMain function. We have a number of other functions and an include file or two, plus some resources. PowerBasic at compile time will compile this down to a single executable file. This exe can then be rolled out to where our users can access it, either on their own personal computers or in a shared folder on the network. Users only need this single file. They do not need access to the source code, the include files, or any of the resource files. This gives you a singular advantage. All the code is wrapped up in one file. But today we're going to be looking at dynamic link libraries. Say for example, we wish to add some more functions to our application. We could of course bring them in as a new include file or build them into the main basic code module. However, what we're going to do today is we're going to create a dynamic linked library. In the source code for the DLL, there is a function called libmain. This is the equivalent of the PBMain function in the application we have created. This is the first function that is called when the DLL is accessed. Other functions can be added quite happily to the file and set to be exported. And when our code is compiled, it will again produce a single file, but this time it's a DLL. So what's the advantage in actually doing this? To see how DLLs came about, we need to look back in time. The capacity of disk drives today is vastly higher than it used to be. When disk capacities were a fraction of what we have today, then placing common code into every single executable did eat away at your valuable disk space. This was especially true when the common code was large and the number of executables was high. Having common code embedded in every executable also means that when some part of the common code needs to be changed, then all of the executables that used that code needed to be recompiled. This generally isn't a problem when you only have one or two executables. If you have 50 or 250 executables, this is more of a project task. One way to get away from this is to have a common code library stored in your DLL. Making a common library like this as a separate file reduces the size of the executables, and traditionally made it easier to make changes to the common library, since it only needed to be recompiled once, and then copied to its live location, either on each user's computer or in the common shared network folder. Another advantage of having a standalone DLL is that other developers can access your DLL without you giving them access to the source code. This may or may not be something you wish or need to do in your own environment. So how does this all work? Without getting into the realms of discussing the differences between virtual and physical memory in modern operating systems, each executable or program takes up space in memory, firstly for its own code and additionally for its workspace. That is the data it's currently working upon. The DLL as a file also takes up space in memory, and the operating system additionally keeps track of how many executables have requested to load the library. If we have two executables accessing the library, there are not two versions of the DLL running around inside your memory. There is only one, and the Windows operating system keeps track of the instance count, the number of binaries which are accessing this DLL. When an executable requests to access the DLL, it's only loaded into memory if it is not loaded already. And when Windows detects that the instance count drops to 0, then it knows that nothing is accessing the DLL and it can then be removed from memory. So let's now go and have a look at the source code to see how we can start to use a DLL in our form application. And here is our application running on the screen. So what we're going to do today is we're going to create a DLL for a number of the functions within our main code module. We're not going to be changing the functionality of the application, so it should operate exactly as it did before. We're merely taking some of the functions out of the main code base into a DLL. So let's go and have a look at the code. So the first thing we need to do is to create a file for the DLL. We can do this quite easily by going up to the toolbar on the top of the screen. And we can select DLL framework using libmain. If we select that, we'll see this is already a template for us to create our DLL. Here is the libmain function. It's taking 3 parameters, but you won't have to worry about these. Further down in this function is a select case statement. This gives you 4 areas where you can put your own code in. This section of code here will trigger when the DLL has been loaded by some other process. This gives you the opportunity to initialize any global data, such as an array, used within the DLL. The next case statement handles when the DLL is unloaded or detached from the calling application. This gives you the opportunity to clean up any and all resources used within the DLL. And we have 2 further sections further down dealing with threads. We're using none of these today, we're just going to add a few basic functions to the DLL. So we will first save this file. And I'm going to call this file commonlib.bas. So we'll now go back to our main code, and we're going to decide which function to move first of all into our DLL. One of the functions within our code is to save the list view. Now we may want to save list views in other applications, so this is an ideal function to move into some kind of common library. So let's have a look at this function. This function at the moment takes 2 parameters, and it does a number of actions on the list view itself. So let's first of all copy this function into the DLL. And there is a function in the DLL. We're going to make some changes to this code to allow it to function as an exported function within the DLL. But let's first comment it out in our original source code. So this function is no longer going to be in our main code module. It will be in the DLL. So what do we need to change to make it a DLL function? Well, first of all, if we look at the header where the function has been defined, we need to put the word export in. This will allow the function to be visible to external applications. Now, if we attempted to compile this now, it would complain because we're using a constant in this function and the constant is not defined in the DLL. This constant is the number of columns in the list view. So what we're going to do is we're going to add an extra parameter to this function so we can pass in the number of columns. And we will substitute anywhere this is actually referenced for that parameter. Now I can also see further down this function we're actually calling another function with a constant. So we're going to have to make some changes here as well. But let's go back to the main code module formDemo.bas and we'll put in this extra parameter. So if we look where SaveListView is actually called, and there is where it is called. Now we need to put in this extra parameter. So there is our third parameter on the call to SaveListView. So we're passing the constant to the function within our DLL. Since we have a function set up, how do we access it from the main code module? Well, we need to declare this function as one that's in a DLL. So if we go back to the beginning of our code, and we're going to declare an external function. So we're using the word declare. It's a specified function there is the name we wish to refer to it from within this code module. We're importing the function from this DLL. Now, we haven't compiled that DLL yet, but we will very shortly. However, there is some more information we need to give this declaration. This is the name of the function from within this code module. However, it may well be that the name of the function within the DLL is something else. If we look at our library, and we can see in here, we've given SaveListView and we've given it export. However, we haven't specified the name of the alias of this function. But we can do that quite easily now by adding the alias command word in with the name of the function. This may seem a little odd. However, if you don't put this in, the name that is exported is all uppercase. This does give you the ability of having the function within the DLL called one thing and the function referenced in your main code something else. I tend to keep the names the same, but if you do have some conflict between the name of a function in a DLL and the name of functions within your own code, then this gives you a way out. So we've changed our alias inside the DLL. So within our code, we can then go ahead and put the alias in here too. So there is our alias with the name of the function. It's important to note that these names are case dependent. So be careful of the case you put in. And there are our 4 parameters. We have the dialog handle, the list view handle, the string we're passing, and the number of columns. Now that we've made those changes, we should be able to compile our main code module. And it compiles quite happily. However, compiling our DLL is going to involve a little more work. As we saw when we looked at this function, there was a parameter we needed to add to remove the reference to a constant. At the bottom of this function, it calls another function, which also uses a string constant. So we'll need to bring this function inside our library as well. This is quite a reasonable approach, as this function saves an array to a CSV file, so it's likely to be a function you will use in other applications as well. So let's go find this in our main code module. Save the array to a CSV file. So let's first of all grab this function and we'll paste this one into our DLL library. So this one is also going to be exported, and we'll need to put an alias in for this one as well. So there we have the alias for the name of the function, and we have it exported. And we're keeping our original 3 parameters. So in this function, there appears to be no other constants or globals referenced. So it's working entirely on the passed parameters. So having saved that, we now have to change this constant in here. This is the name of the list view to save to disk. So we're going to have to bring this in as another parameter. So let's replace this constant with a parameter. So we will change that to this list view grid, and we will add this in as one of the parameters. So now we have an extra parameter, one for the file name of the list view and one for the number of columns. And this parameter we're passing in is passed on to the function that saves the array to the CSV file. So because we've changed this, we're going to have to change our declaration in the main code module. And there is our parameter, the 3rd one on the list, the name of the file to save. So if we look to where this function is actually called, so in here when we call SaveListView, we have our 4 parameters, the handle of the dialog, the handle of the list view grid, the path and name of the file we wish to save to, and the number of columns. So before we compile and run our application, we'll need to comment out this save the array to CSV file, which now exists in the DLL. So if we attempt to compile that now, it compiles cleanly. Our DLL can be recompiled, and it compiles also quite cleanly. So if we have a look in our folder, we can see there is our form demo exe, and there is our common lib DLL. So if we double click on the exe, we have our details on screen. So we'll make a minor change to one of the details. And we'll take off Shift 3 and push the date forward. And we'll attempt to save. And this will have now saved to a CSV file. So if we exit and run the app once more, it should come in quite happily with a single shift for this particular user. So what we've achieved so far is we have amended our application to use a DLL. And we have moved two of the functions within our main code module into that DLL. So let's see if we can move another function. Since we're handling information that passes to and from the list view, there's a function in our code which reads a CSV file into an array, which is then used to populate that list view grid. So let's go back to our original code and find that function. And there it is, read the CSV file into an array. Again, this is a very common function. You may be loading many CSV files into arrays throughout your applications, so this is an ideal one to go into our library. So again, we will copy that. We will comment it out in our main code. And we will paste this one into our library. And as before, we'll need to put the export in. And of course, we need to give it an alias. So there is our function with its alias quite happily in, matching the name of the function. And we have it marked as exported. Now this is a fairly generic function, and it doesn't appear to be using any constants or global data. So it should compile quite happily, which it does, so that's our DLL created. And we now have to declare this function at the beginning of our code. And there is a declaration of our read the CSV file into an array. If we save that and compile our application, it should compile quite cleanly. Now, as you can see, we have two declarations here, one to save the list view and one to read the CSV file into an array. In the library itself, we have three functions. We have additionally the save the array to a CSV file. Now, although we've marked that one as export, we have not yet declared that within our application. This is because we don't actually need to. In the code library, this particular function is called from save list view. At the end of that function, it calls save the array to CSV file. So at the moment, this function is only internally referenced within the DLL. So technically, it doesn't need the export. But just because our application at the moment doesn't call this directly, future applications might. So I've marked this one as exported. So we go back to our original code, we recompile, and we run. It has already run the read the CSV file into array to get the data which was used to populate this list box grid. So in summary, what we've achieved today is we have taken three functions out of our main code. We've moved them into a DLL and marked them all as being exported. Although we're only using two of these functions directly from our application, three functions are declared in the DLL. This would mean the DLL could be used by other applications accessing all three of these functions directly. Of course, one thing to remember is we started off with a single binary file, an executable. And this had to be rolled out to our users. We now have two files for our application, the exe and a DLL. If the DLL is not present, the exe will refuse to run and give an error message. However, the advantage you gain in having these functions in the DLL is if we need to change the content of a function without changing its interface, then we can do that by just changing the source code for the DLL and then recompiling and rolling the DLL out to its live location or locations. The individual applications do not need to be recompiled as long as the interface between the application and the DLL has not changed. Hopefully you'll find this approach and this code useful in your applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.